Hello, I'm Alex Savchik, and I'll present our work, Agricultural Parcel Localization, on satellite images using UNet-based neural network. What is agricultural parcel localization? We have some satellite imagery, and we want for each pixel to identify, is it correspond to some parcels or fields, or is it background pixel? Related task is boundary localization. It can be used in some tasks such as cadastral information or for semi-automatic parcel segmentation. To solve this task, we use machine learning approach. So there are a lot of satellite image data from, for example, Sentinel-2 satellites. This data is multi-channel, but we mainly focus on 4 channels: true color images, or usual RGB, and NDVI, one of the channels based on near infrared band, and often used in agriculture problems. To make there are a lot of images, but the problem is annotation. So we downloaded about 20 images with quite a big resolution, and mainly annotated parcels on manually annotated parcels on them. Actually, there are a bit more images because there are different seasons and there are several images of the same place from different time. So with quite a few changes, we managed to obtain not 22 images, but 122. To solve these tasks, we used quite typically for segmentation tasks neural network architecture, the UNet one. UNet was presented in 2015, and it is actually an encoder decoder, which use max pooling and upsampling to firstly decrease image resolution and then increase it to the original one. And at the same time, it has skip connections to calculate data without resolution change. Such an architecture is very efficient. It has quite computationally hard. It can use computationally hard features in low resolution and use this information in the original resolution for fast, more accurate pixel-wise prediction. We used a bit different architecture than the original one with minimal changes, with 32 channels, not 64, with all levels, not 5. So this neural network trained on our trained data, was able to predict these answers on test data, on independent test data. We see that the parcels and boundaries are found not very good, but much better than the random one. And the same result we can see in our matrix. The random boundaries and random parcels give much worse result than we obtained. So these methods could be used, but the input and output data dependency is not as big. We experimented with several inputs and outputs with multitask approach when we tune network to find parcels and boundaries simultaneously and then calculate metric only for one of the outputs. But the difference between this approach on our data was not reliable. Sometimes it's bigger, sometimes it's smaller, but with three experiments for each variant, we obtained not only the result estimation, but the standard deviation estimation, and we see that the difference is not very reliable. It's not significant. So for conclusion, we might say that these methods have proof of work, but to make better predictions, we need more data. Thank you for your attention.